Write and solve an inequality. So this Rosa person sells radio advertising in 30 and 60-second time slots. During every hour, there are up to 15 minutes available for commercials. So this means like I could watch a minute-long commercial, I could watch 15 of those, and if they were all 60-second time slots, that would max it out. So it sounds to me like they wouldn't be able to do 16 60-second commercials. In other options, though, you could have 30 of these. So that means that, there's 2 per minute. And if I multiply that by 15, I get 30. So I could get 30 of those 30-second commercials. And since it says up to, I guess if you wanted, you could really have a pretty poor managed situation where you just sell one of these and one of those, or 2 and then 1. But it sounds like there's a lot of different solutions to this. How many commercial slots can she sell for 1 hour of broadcasting? So let's define some variables. Well, it sounds like the different variables are 30-second slots and then 60-second slots. So I'll put the words ADS, so the letters ADS to represent ads. So there's 30 and 60-second ads, and then I'll just do X and Y. And let's think. The limiting factor is that 15 minutes. This number and that number isn't going to show up exactly the same way. And we have to have all of this has to be less than or equal to the 15 minutes. Well, I guess, we could just have a certain number of Y ads and a certain number of X ads, but I wouldn't just do X plus Y, because this one works out, because if this was 0, then we agreed on that number 15, because they're each a minute long, but these ones right here, when I'm dealing with time, are a half a minute long. So if I did a half of it, then this would represent 30 seconds, while this would represent 1 minute. If that's unclear, we can work on this one together. It's a little bit more complicated when you're dealing with something like half-time. So I have half X plus Y is less than or equal to 15. Now let's set up our graph. Instead of drawing a quadrant in the middle, I'm going to set up my graph so that it's in this direction and in this direction. And when I'm thinking about where would good stopping points be for this, well, we talked about how there was a limit of 15 for these ads, so maybe this becomes 15. And I interrupt this with a 10 and a 5 stop. But then with X, we talked about how the max would be 30. And then here's my 10 and 20. And if I could really just say to myself, well, we already kind of figured out what those answers would be, so I'm guessing that they're going to be here and here. But we'll solve this like a typical inequality we've already seen. And I'll have Y is less than or equal to negative 1/2 X plus 15. Now if I just pretend that this is a line without inequality, I see my y-intercept of 15. But when dealing with a real-world problem, it's often nicer to think, well, what is the value of x or y at this point? Well, at this point, y is 0. So if I plug 0 in here, and let's make this work you actually do. Here's 0 equals negative 1/2 x plus 15. Subtracting 15 from both sides, I'll just move that over. And that's going to give me negative 15. And then I'll multiply this by negative 2. That's very unclear, sorry. And multiply that by negative 2. And I'll get positive 30 as x. So I figured out that at 30, 0, I have another value. Now we hand drew this, and if we are hand drawing graphs, and I were to try and count down 1 over 2, 1 over 2, 1 over 2, I might hit that point, but I'd have to be very accurate in my graph, and I don't think that's very reasonable. So I think the better way is to actually set things equal to 0 so that you can figure out what your y-intercept is, figure out what your x-intercept is, and then when you go to draw your line, decide first, should it be connected? Well, it should be connected because it's less than or equal to. And then when we go and we draw this line, and you have a straight edge or a ruler, yours is way accurate. Now this is a real-world problem, so if I use real-world logic, I wouldn't shade over here, because that would be like a negative add, and that would be negative add, so that's unreasonable. So even though we haven't talked about it, both x and y have to be greater than or equal to 0, so we'd want to shade this region. And I just jumped into shading that region because this is a real-world problem. If I think about it in the context of the real world, it does not make sense to shade where I've drawn this face. But the cool thing is, the math and the problem should agree. So if these two don't agree, we know we made a mistake. So let's plug in a value like 0, 0 and make sure it still works. 0, 0, that drops out this term and this term, and 0 is less than or equal to 15. So when I plug in that coordinate, it checks out with the real-world problem, and it also checks out with the math we came up with. Let's move on to the next one. Neil wants to run a marathon at a pace of at least 6 miles per hour. Write an inequality for the miles y he will run in x hours and graph the solution set. In case this throws you off, just think, well, 6 miles per hour. And I'm curious to know how many miles he can run. So I wouldn't multiply this by some random number. I'd multiply it by the time in hours. And if I did that, then that would drop out my hours and leave me with miles. But the other thing, too, is you might be pretty practiced with the distance formula and speed. So you'd be like, well, I guess it's just 6 times x, and I'm good. And that's going to give me y. So it might be pretty straightforward. Now, he wants to run at least that many miles. So he hopes that y is greater than or equal to 6x. There's no need to have negative numbers. So I'll draw my graph like this. And when I go and I graph this line, maybe I'm just like 5 over for x, which then would give me 5 times 6 is 30. And I'll put a point up here. And I'm going to draw a solid line. And if we want this to be greater than, we would shade above. Now normally we would shade this region over here if it was not a real-world problem. But since it's a real-world problem, we are going to be bound by negative time. And so we will not shade to the left of that first line or below the other line. And if you wanted to check a value out, here's where it kind of gets a little interesting. You can't check 0, 0 out because that's on the border. So you could check a value like 1, 30. Well, 6 times 1 is 6, and that is less than or equal to 30, so you'd be good there. Now in the real world, he's probably not going to be running anything so outrageous, like to where he's going to run for an hour and then finish 30 miles. That's just unreasonable. So this would be this answer to this problem. I made a note here, no need to redraw graphs, but that's for 27 through 33 all only. The other ones I would like you to draw graphs. And I would encourage you to graph these on your own and not use graphing paper. And that's because when you get to college algebra classes, you want to have skills in place to be able to draw parabolas and all kinds of different math relationships. Word problems, these are likely going to be challenging. That's totally okay.